Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. The last time we met, we wrapped up our segment on logistic regression analysis. In the next two videos, we're going to be doing some chi-sqared tests. So we'll start by cleaning our data and then analyzing it. And usually when we do a segment in R for BRFSS, we also visualize our data, but I don't know how to visualize chi-sqared data. So we're just going to analyze it and make a table, and that will be that for this segment. So first we're going to read our article, then subset our data file based on the variables that they use in that article, and then clean our data. So the article that we're working with is called Prevalence of Secondary Conditions Among People with Diabetes. And lucky for us, this actually is available for free open access online. So let's find it. Prevalence of, I forgot the article name. Prevalence of secondary conditions among people with disabilities. And it's available from PubMed, from PMC, full free text. So you can go ahead and download it from here. All right, I'll just open the PDF and let's start looking at what these authors analyzed. All right, so they are using data from the Behavioral Risk Factor Surveillance System, but they're looking at the 2001 module for Washington State related to adults with disabilities. So we're not working with Washington data, we're working with California data. And also California in 2017 didn't have a specific module related to disabilities. But there are some variables in the 2017 BRFSS survey anyway that are kind of comparable, so we'll try to mimic the variables that they used as closely as possible. So let's just scroll down a little bit into the methods section. They describe that module on disability was composed of 16 telephone survey questions. And the way that they define disability is kind of, I'm not really sure what they mean when they say persons who met the BRFSS disability criteria were asked, the following 16 secondary questions related to secondary conditions. So I'm not sure what disability criteria means, but there are some questions in the 2017 BRFSS data that I kind of we'll end up using to make our own definition of disability criteria. All right, so that's the study population we're looking at, people with disability. And the secondary conditions that we're interested in are chronic pain, sleep problems, extreme fatigue, weight or eating problems, periods of depression, skin problems, muscle spasms, respiratory infections, falls or other injuries, bowel or bladder problems, serious episodes of anxiety, lack of romantic relationships, problems getting out or getting around, problems making or seeing friends, feelings of being isolated, and asthma. So those are the secondary conditions. In their analysis, they display their findings in this table describing the rate of people having disabilities that also have the secondary condition among the people among their total population, then the standard error, then the rate in the disability group, the standard error, the rate in the non-disability group, standard error, and then the chi-sqared test for independence. And then these asterisks are the p-values, so whether it's statistically significant or not. All right, so we're going to try to replicate this table. And the variables that we're looking at kind of coincide with the ones that the authors from this paper looked at. So as we've been doing previously, I tried to match up the conditions described in the paper with the health variables described in the BRFSS codebook, and then identify the response value that we want to recode to 1 for our analysis. And so a number of them did kind of have some comparisons, but some were in the BRFSS survey from 2017, but were module questions. So they were either not included in California or would have required a different weighting frame. So to keep things simple, I just excluded module questions. I excluded questions that didn't have a comparable alternative in the 2017 data. And so we end up with let's see, 1, 2, 3, 4, 5, 6, 7, 8. It looks like 8 of the health variables matching the conditions described in the article. All right, but we also have to set our definition for disability criteria. So in the 2017 BRFSS survey, let's go ahead and open up the codebook. So CDC BRFSS 2017. Open the first result, go to the codebook. All right, so in the codebook, when we search for disability, we get a couple of results, but they're not asking about an individual's disability status necessarily. One question is, do you have Medicare? Do you provide care for somebody with disability? What is the main problem of the person that you care for, the person having disability? Oops. And then in the next 2 years, do you expect to provide care or assistance to somebody with disability? So the questions in the 2017 BRFSS codebook related to disability are not about the individual, but about the individual providing care to people with disability. But if we search for difficulty, there are a number of questions related to an individual's personal difficulties, which we can kind of translate to a form of disability. So one is difficulty hearing, so that's this variable called deaf. The next one is difficulty seeing, so the variable called blind. Difficulty concentrating or reminding, that's this decide variable. Difficulty walking or climbing stairs, that's DIFFWALK. Difficulty dressing or bathing, that's called DIFFDRES. Difficulty doing errands alone, DIFFALON. Oh, and then there are some questions related to sleep, but this is also a module question, so we didn't include it. So basically, of the difficulty questions, we end up with 6 that we are using to define our disability status. All right, so let's open up a new R session and start looking at and cleaning our data. So we'll set our CranMir, packages, set CranMir to the cloud, okay. Let's set our directory, file, change directory. Mine's on the desktop in our folder called R for BRFSS. We'll be working with 3 packages today, so let's load them now. Library tidyverse, which I spelled wrong. Library tidyverse. Library survey. And library survey R. All right, so first thing we want to do is load in our California Girls 17 data file that we subset way back, like within the first 4 videos or something. So we'll call that California Girls 17 assignment arrow read.csv parentheses quote California underscore girls 17.csv end quote header equals true. And let's glimpse that and make sure it looks correct. California Girls 17. All right. So we have all 9,355 of our observations from California and all 240 of our variables, which should look familiar to you because we've been working with this main California Girls 17 dataset since almost the beginning of this tutorial series. So what we want to do is subset this data file to only include the variables that were described in the article. So again, I thought it would be much easier and I would have a lot fewer typos if I just kind of verbally walked you through the code that I've already typed, and we can copy and paste it into our console and then just run it and then it will work automatically and I don't have to type as much. So that's what we're going to do. So to subset our California Girl 17 data file, which we just read in, we're going to call this new data file CG17 underscore chi-squared for California Girl 17 underscore chi-squared for our chi-squared segment. So we'll start with the California Girl 17 data file, then pipe, right? So start with the data file, and then everything following includes the data file from the other side of the pipe, right? So the function we're using is called select, and we want to select these variables. All right, so we have our 3 weighting variables. We're still interested in the respondent sex, so we'll include that as kind of another demographic. And then these are the health variables that we identified that matched the article. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 secondary conditions. And then we identified 6 disability-related questions that we'll use to set our criteria for disability. Okay, so let's go ahead and run that code to subset our data file. Take a glimpse at CG17 underscore chi-square, and it looks good. We still have all of our observations, and we have 18 variables. And of course, our variables are not the correct class. Most of them are integers. Here we have a double. Actually, for the weighting variables, it's not really a concern for us. But these other variables, we want them to be factors, and we also want to clean up the response options so that we're working with 0s and 1s instead of 1s, 2s, etc., and missing data. So I've already cleaned it, and I'll just walk you kind of line by line the way that we've done that previously. So let me put a page break in here. The first variable is the respondent sex. So in our California Girl 17 underscore chi-squared data table, we want to change that sex variable to a factor and recode 1 to M, 2 to F, and everything else to 0, default to 0 and missing to 0 as well. And actually, our original California Girl 17 data file only includes male and female respondents, so we don't have any missing data and we don't have any other data, so we don't have any default data. But just for consistency, I put this at the end of our recode function anyway. Okay, the next variable is this one related to joint pain. It's called limit joint 3. We want to set it as a factor, recode 1 to 1, and everything else to 0. The next one is X underscore RFBMI 5. That's overweight or obesity. We want to set it as a factor and recode 2 to 1 and everything else to 0. And then most of the other variables, we want to recode 1 to 1, except for this one, X underscore phys14D, which is somebody having 14 or more days of poor physical health in the last month. So we want to recode 3 to 1. And for this variable mental health, which is somebody having 14 or more poor mental health days in the last 30 days, we also want to recode 3 to 1. But for the other variables that I haven't described yet, again, we're setting as a factor, recoding 1 to 1, setting the default and missing to 0. All right, so this is that. However, for our disability-related questions that we'll use to set our disability criteria, we want to keep these as numbers because what we're going to do is we have 6 disability-related questions. So we are going to look across all 6 of them and add those up. And if somebody has 1 or more of these disabilities, then we'll consider them a person having disability. Okay, so we want to recode. We want to set it as numeric and recode 1 to 1. So in this case, 1 means yes, I'm deaf. 1 is yes, I'm blind. One is the response in the affirmative that they do have this disability. So for all of these, we'll reset the affirmative response to 1 and everything else to 0. So in that way, we can sum up the affirmative answers to these 6 questions and find people who have at least one disability related, who responded positively to at least one of the disability related questions. And the way that we calculate, the way that we add up these values is by using this function called row sums, which we used before on the segment for market basket analysis when we were looking at comorbidities. So we use this function called row sum, where we look at the sum of the columns 13 through 18. So in our data file, we have 18 variables starting at column 15 through 18. These are our 6 disability-related questions. And so we're going to sum up those columns for each individual, so for each respondent on the row, and we will call that variable dis_sum for disability sum. And then we're going to, from this dis_sum variable, we're going to create a new variable called dis. We'll make it a factor, and if somebody has 0 disabilities, we'll keep it as 0. And if they have anything besides 0, so 1 through 6 disabilities, we'll recode that as 1. So for this dis variable that we're creating, 1 means that yes, they have a disability, 0 means they have no disabilities. Finally, we will also differentiate between male and female, so we'll create 2 additional variables based on the sex variable, where for male we'll recode M to 1 and everything else to 0. For female, we'll recode F to 1 and everything else to 0. So that is a lot of data cleaning. Let's go ahead and run that all. So I'm just copying it and pasting it over. Let's run that. Good, and I don't see any error messages, so let me make this a little shorter on the screen. Okay. Let's glimpse our California Girl 17 underscore chi-sqared. Okay, so it looks good. So we have all of our observations still. Now we have 22 variables. Before we had 18, but now we have 22 because we added this dis_sum variable, which is the sum of the disabilities that people have from these 6 disability-related questions. This is the dis variable is the response options are 1 and 0. So yes, I have a disability, or no, I don't. And so if we look here, we can see that it looks like that variable recoded over correctly because, for example, the first respondent had 4 disabilities, so they have a 1 for the dis variable. The next person had 2, so they have a 1. The third person for dis_sum had 0, so for dis they have 0, right? And you can see it goes along like that. When somebody has 1 or more disabilities, then they get a 1 for dis. If they have 0 disabilities, they have 0 for dis. All right, and then finally we have our male and female variables at the bottom, just because we'll want to look at that later when we're thinking about our overall hypothesis for this course related to California girls having better health than California boys, which is kind of our fake hypothesis for this course. All right, and I just wanted to verify that the dis variable, that the dis_sum variable has a range between 1 to 6, or rather 0 to 6, because we have 6 disability-related questions. So our maximum for the, what's our data file called? CG17 underscore chi-sqared $. So the max for the dis_sum variable should be 6, and it is. Likewise, the minimum for the dis_sum variable should be 0, which it is. So it looks like our data is cleaned correctly. All right, so that was pretty easy. Next, we're going to set our survey design and analyze it. So yeah, I will keep my R session open and just pick up where we left off, but I'll end the video now and see you back here really quickly. All right, so bye.